All right, my name is Teria Dankwa Samuel. You are welcome back to today's lesson. All right, so in today's tutorials, we are going to look at the conjugate set and rationalization of a set. All right, so let's start with the meaning of conjugate. All right, now given, so in case we're given, let's say, root x minus root y. Now the conjugate of this becomes root x plus root y. So look at the sign. So just change the sign. So one is the conjugate of other. So in case you are given this is the conjugate. All right. So in case we are given, let's say, 2 plus 5, this conjugate becomes 2 minus 5. All right. So try this one. 1 minus 2. What is the conjugate of this? All right. So you can write the answer in the comment section below. All right. So you can write the answer, and also in case we are given 4 plus 7, what will be the conjugate? So just change the sign. So it's 4 minus 7. All right. Now that we fully understand conjugate, what a conjugate set is, let's quickly look at what a rationalization of a set is. All right. So sets of the form 1 over root a. Now sets of this form can be rationalized, okay, by multiplying both the numerator and denominator by the denominator here. So this one is times this times that. So we have 1 times root a, then root a times root a is a. So in case you are also given 1 on root b, so just multiply both numerator and denominator by this. So we have root b, then you do the needful. Okay, so this one is case 1. So this is case 1. All right. So another example, in case we are given, let's say, 4 over root c. Okay, so we can do this, or we can solve this one by rationalize. So we take root c on both sides. So both numerator and denominator will be taken root c. Okay, so 4 times root c is 4 root c. Then this time that will be c. All right. So let's look at case 2. Now case 2. Now in case let's say 1x plus. All right. So this one too, we have to multiply both the numerator and denominator by the conjugate of this. So we have x minus y on root x minus root y. All right. Then you do the multiplication. All right. So with this, let's look at the denominator here. And the denominator is behaving like this. So in case we have b squared minus a squared minus b squared, the same as a plus b, then a minus b. So we call this difference of two squares. So we have root x plus root y, then we have root x minus root y. So this one is the same as root x all squared minus root y all squared. So just as this one is equal to this. All right. So let's solve examples. So I'll throw more light on this when we get there. All right. So let's look at the following examples. So we are to rationalize the following. cells. All right. So this one is straight away. So I'll just multiply both the numerator and the denominator by the denominator here. All right. So 1 times root 2 is root 2. So this time this becomes root 2 squared or root 4 or 2. So we have 3 things. So this side will be 2. And it's the same as 1 over 2 root 2. Alright. Or you can leave it like this. Okay. So let's look at the second example. We have 2 on 2 5. Okay. So we have 2 ways of doing this. Now, first, you can ignore the coefficient and multiply by the set, or use everything here. So let's look at the first step. So I will take everything. So 2 5. All right. So the numerator will be 4 5. Numerator, now this one multiply this 2 times 2 4. Then this one to multiply this 5. Okay. So this one will cancel this. So we have 5 over 5. Method 2. So same question, 2 on 2 5. Now let's use the set alone. So I'll multiply both the numerator and denominator by the set times that. Okay. So we have 2 times 5 to 5. Okay. Then what's the equation here? 1. 1 times 2, 2. Now with 5 times root 5 is 5. So this one will cancel. So we have root 5 on 5. So we check this and that. Alright, so we have the same answer. Alright, so let's look at this one. So let me divide this to 2. Alright, so we have 1 over 4 minus 5. Okay, so just as I said, so we are going to look at the conjugate of this. So I'll multiply both the numerator and denominator by the conjugate of the denominator here. So I'll change the sign. Alright. So plus. Alright. So let's look at the denominator. So in case we have, let's say, x squared minus y squared, the same as x plus y times x minus y. So we call this difference of 2 squares. So let's check. We have 4 minus root 5, x plus y. So we have this, that. Okay. So this is what we are going to do. I'll pick the one with the minus. So I'll pick the one with the minus, and I'll square the first one. I won't worry myself going through the multiplication process. So I will square this minus, then I will square this too. Of course, if you go through, or if you use the multiplication process by taking this to multiply this minus with 5 times, that you get the same thing. But I think that one will be a long process. So now denominator 1 times that. So we have 4 plus 5. All right. So 4 plus 5. So this one will be 16, and this will cancel, minus 5. All right. So we have 4 plus 5 on 11. Okay. Or we can say 4 over 11 plus 1 over 11 5. So this one is also correct. All right. Now let's move on to the next example. Now with this example, it's not different from what we just did, just that we have to square this one. Now in case you have, let's say, a minus b all squared, this one is a squared minus 2ab plus b squared. All right, so let's square this one first. So 1 minus 5 squared is same as this one multiplying itself. Okay, so 1 times 1 is 1. 1 times this is minus 5. Okay, minus with 5 times 1 is minus with 5. Minus with plus, so we have 5. So let's look at this one. So the coefficients is 1, 1. So minus 1, minus 1. So we have 1 plus 5, that is 6. Then minus 2 with 5. So we have 6 minus 2 with 5. Or we can use this. Okay. So I'll square the first term, 1. Then I'll multiply everything in the bracket by 2. 2 times 1 is 2. So we have times minus with 5. So we have minus 2 with 5. And I will square this one. So I will get plus 5. So we have 6 minus 2 with 5. So this one is equal to this. Okay, so this one is the same as 1 over 6 minus 2 with 5. So we are going to work with this one. All right. 1 over 6 minus 2 with 5 times. So let's look at the conjugate. So we have 6 plus 2 with 5 over 6 plus 5. All right. So 1 times that denominator, we have 6 plus 2 5. So this one we can difference of 2 squares. So I'll pick this one, the one with the minus. Now I'll square the first. Now I'll square this one as well. All right. So we have 6 plus 2 5. So 6 squared is 36. Minus, now we have to square everything. So 2 squared is 4. Then with 5 squared is 5, because it will cancel. So we have 6 plus 2 with 5 over 36 minus 20. So we have 36 minus 20, that is 16. All right, so we have 16. So we have 6 on 16 plus 2 on 16 into 6. So 2 here, 3, 2 here, 8, 2 here, 1, 2 here, 8. So we have 3 over 8 plus 1 over 8 with 6. So this is the answer. All right. Okay, so let's look at this one. All right, so let's look at this example. We have to express this in the form of this. All right, so let's start. So same thing, don't forget about the conjugate. Okay, so we have this. So 3 plus 2. So the conjugate will be 3 minus, then so we have this. All right, so the denominator is difference of 2 squares, so I'll pick this. So we have, and I'll square this, and I'll also square that. All right, so let's multiply this one. So this one is 3 minus 3 with 2. Okay, so more or less this one behave like this one squared. So it's the same as 3 minus 2 all square because they are equal. Alright, so let's take them one by one. So I'll use this root 3 to multiply this. So 3 times 3 is 3. So okay, let me write them one by one. So we have 3 minus 2, then minus 3 root 3, minus 3 root 2. We'll take the same thing. Alright, so let's start. So 3 times root 3 is 3. With 3 times this, so the coefficient here is 1. So we have minus 3 root 6. So we are done with the first bracket. So we scan 1 minus 3 times that. The coefficient here is 1 minus, we have minus 3 root 6. Then minus 3 root 2 times this. I'll get plus 9 times 2. So we know the properties. Okay, and this one will cancel this. So I believe with 3 minus. So let's square everything here. So 3 squared is 9. Then 2 squared will be 2. Okay. Alright, so let's move on. So we have 9 to 18. So we have 18 plus 3. Okay, now let's deal with this one. So we have minus 3 here, minus 3. So I'll get minus 6. Minus 6 with 6 over. So we have 3. Now minus 9 to 18. Now mind you, this one is one entity, so you can't touch it. Okay, so we can deal with this. So 18 plus 3 is 21. Minus 6 with 6 over minus 15. Alright, so this one is the same as 21 minus 15. So of course this side will be minus, so okay, minus 6 minus 15 with 6. Okay, so we have 3 into 21. So 3 7 21, 3 5 15. So minus minus with plus. So 3 2 6, then 3 5 15. So we have this as our answer. Alright. Okay, so let's look at the next one. So we have 8 plus 5 with 32 minus 4 with 50 on 1 plus with 18. So let's apply the properties, the reduction form, and what have you, all that we've learned. So let's break 8 into 4 times 2, okay, plus 5. So 32 will be 16 times 2 minus 4. So 50 is 25 times 2. So 1 plus, so 9 to 18. Alright, so we have 2. So make sure you watch the lesson 1 and 2 before this. Alright, I've taken my time to explain all these things. So we have 5 times that. So we have 5 times 4 with 2. Okay, so then minus 4 times with 5, sorry, 25 will be 5 with 2. Alright, over 1 plus, so this side will be 3 with 2. Okay, so we have 2 with 2 plus, so we have 20 with 2 minus 20 with 2 on 1 plus 3 with 2. So this one will cancel this. So we have 2 root 2 on 1 plus 3 root 2. So let's move on. Having finished, so we can multiply both the numerator and denominator by the conjugate. So have that. Alright. So the numerator will be, so this time that is 2 root 2 minus, so 2 times, so it's 6, 2 root 2 with 2. And the denominator is difference of 2 squared. So we have 1 squared minus 3 root 2 all squared. Alright. So we have 2 root 2 minus 12. Alright, so we have 2 root 2 minus 12 on, so the numerator will be 1 minus, so this 1 squared will be 9. Then this one, the root sign will go. So we have 9 times 2. Alright. So we have 2 root 2 minus 12 on, so we have 1 minus 18. Alright. So we have 2 root 2 minus 12 on minus 17. Okay, so we can break this one by saying 2 root 2 on minus 17 plus 12 on 17. Alright, so that's that. Alright, so let's look at this. Very simple. Given that root 5 equals 2.2360, find the value of 1 on root 5. So this one is not difficult. So let's look at this 1 on root 5. So let's rationalize this one. So the numerator will be root 5 on 5. Okay, so we know this. So root 5 is 2.2360. So let's substitute 2.2360 on 5. So calculator work. So take a calculator, then point this, then write the answer down. Alright. Alright, so let's move on to the next example. So same thing here. So we have root 2 equals 1.41214. So let's look at this. So this one is not difficult. We have 3 minus. So let's look at this. 2 on root 2 times 2. Okay, so we have 3 minus 2 root 2 over 2. That is very, very simple. So we have 3. Now this one will cancel. 3 minus root 2. But root 2 has been given. So we have 3 minus 1.41214. So let's subtract